Hi everyone. How you guys doing? Cool. We are entering the last section of the Tech Summit. The hard part of doing a session right after lunch, I know I'm competing. I have a very strong competitor at this point. You guys had a good lunch? Yeah, no? Are you guys ready to sleep? If the session is too boring, is the chair comfortable? It's better not be. Well, thanks for joining this session. My name is Vinicius Apolinario. If you are wondering how to pronounce that name, anyone here have been to my session yesterday on security? A few of you. This morning on SDDC, some of you. Yeah. So for those of you that did not hear the joke from yesterday, if you are wondering how to pronounce my name, that's Vinicius Apolinario, and there's a funny story about that. So my first name is Greek. My middle name, that's not there, is Ramos, which is Portuguese. My last name is Italian. I'm from Brazil, and I live in the US, right? So yeah, I do have problems when people, what's your name, sir? There's absolutely no name that I can give that an American will be able to pronounce correctly. Even if I'm going to whatever part of the world, people can't pronounce my name, so yeah, no worries about it. The next thing is I'm a product marketing manager for the Windows Server team at Microsoft, and usually when we come to this kind of events, people see marketing manager, and the marketing part doesn't help me, right? Because people are expecting to have some kind of technical conversation. So bear with me, I do have a technical background, so we can probably have a good conversation on Windows Server, right? Again, thanks for joining the session. Another thing that I'd like to ask you guys is to please participate, right? The reason why you are here and not checking an online video is because you probably will have questions. You want answer to your questions, so please raise your hand. I'll repeat the question because we don't have any mics in the room, so people that will watch online can hear your questions, and then I'll answer the question if I know the answer, of course, right? So this session is on Windows Server 2016 application platform. How many of you guys have an idea on what application platform is, or at least think you do? Yeah, so you guys have no idea why you're here, right? Okay. Application platform is, taking a step back, if you look at Windows Server has many roles in the data center, right? First one, and probably the most notorious one, the one that Windows Servers really has built a reputation on, is infrastructure, right? So I want to run my directory, my Active Directory. That's Windows Server. I want to run my mail services, Exchange or whatever other email that runs on top of Windows Server, maybe you run Windows Server. I wanted to run my website. That's Windows Server, right? So those infrastructure pieces are actually, website is kind of application. So think about DNS, DHCP, storage, networking. So another area that Windows Server is very important is websites, applications, and other stuff, right? At the end of the day, Windows Server is the base for either your infrastructure or your applications, right? This session is about applications, how Windows Server can support the next generation of applications. We are not talking about legacy stuff. We will talk about some of this, but the technologies that are new to Windows Server to support the new development model and the new technologies that are coming up. So the two features that we'll talk about are, if we can say feature, containers, and we'll talk about Nano Server, right? Those are the two things that I want to cover in this session. Sounds good? Okay. Anyone has had any different idea when you joined the session? No? Okay. And another important point is, another question for you guys. How many of you are developers? Okay, so we can't say bad things about developers in this session. We said a lot of bad things about developers in the other ones. IT pros, okay, I think that's everyone. But any database administrator, maybe as part of the IT role as well, probably, okay. For the developers and the others as well, but mostly for the developers, how many of you have been using containers already? That's great, awesome. None of you, because we are here to explain what containers are, right? What I was afraid was someone that have been using containers is here to hear what containers are, so that would be the wrong session. So let's keep going. So the first thing that I would like to highlight in this session is what is the driver to what we're doing in Windows Server to support the new type of applications? What's going on, right? And when we think about what cloud is causing to the data center, that's probably the main thing that is driving the changes that we are seeing for both development and infrastructure, right? I was talking to a customer the other day, and he was saying that they are a startup. They started like a few months ago, and they are already operating in 5 different countries in a matter of months. And the only reason why they can do that is because the technology behind this company's product or service, the technology that they decided to use, uses cloud to scale, to reach their customers, and so on. So this type of company is only possible nowadays, because cloud enables those companies to operate like that, right? So cloud is providing companies hyperscale, so companies that are small in terms of number of employees, for example, can operate in large scale, right? Availability. Even small companies are processing millions, billions, maybe trillions of dollars because they have the availability to do that. Maybe small companies, if their service is not available for 5 minutes, they end up losing a lot of money, regardless on the size of the company, right? And agility is another component here. That company was able to bring to market the service that they developed in a matter of 1 month or a few weeks, and their minimal viable product was enabled with the agility that cloud allowed them to deliver to the market, right? I have never seen something like that. In the past, to be able to hyperscale like this, you will need to buy hardware, or you will need to go to different vendors in different places that will have different requirements. The application probably wouldn't run the same way, and so on and so forth. In terms of availability, how can a small company have such availability, such SLA, compared to other enterprise customers that struggle to provide high availability for their services, right? And the agility, they are able to implement new features or new services in their portfolio very quickly, right? Their developers are constantly working on improvements to their application, and they can simply deliver that new feature or that new service to their application or service running once they test it and it passed from the test, and they can just go to production. Compared to probably the companies that you guys work on, if you guys are large or medium companies, you have some kind of development in-house, how can you guys can quickly develop something, test, and go to production? Most of the companies that we talk to, they struggle with this process, right? So one of the things that we started to realize is that all those tensions, they drive the change that we are seeing today. Since we have developers and IT pros in the audience today, let me ask you a question. Tell me if this is familiar to you guys. We have a development team that creates an application. They test the application. They do all the quality tests and proof of the application and so on. Now they bring the application to production, and the application doesn't work. Have you guys seen this before? No, it doesn't happen in your company? Yeah, I would bet it doesn't happen in your company. But anyway, it happens to most of the customers that we talk to, right? And why is that it? Why does this happen? Most of the cases, there are some cases where it was not implemented correctly, or there were some bugs in the applications. Most of the time, in the vast majority of the cases that we hear this situation, there's some kind of requirement that was there in the development environment and is not present in the production environment. Requirement for the application, I mean, right? Now, at that point, we start the pointing fingers war, right? Operations will say, well, we just implemented your application. If it doesn't work, that's a development problem. But the developer will say, well, we tested the application, so if it doesn't work, that's the infrastructure problem or the operations problem, right? So it was time to create some kind of technology that will help solve this problem, right? I work in IT for, I don't know, more than 15 years now, and my entire career I heard conversations like this. The answer to that is what we are calling as microservices. Microservices, you thought I was going to say containers, right? So containers is part of the microservices story. Microservices assume one thing that we've been doing in IT for a very long time, which is when we create an application, we try to package everything that the application needs inside of a package. Then we move from environment to environment, right? And we create some dependencies from that package to the operating system or to the system where that package is running, right? So in order to deploy an application, I have to configure the entire operating system, so every time the application will call the operating system, everything that the application will need will be there so the application can run, right? What microservices is doing is decoupling the application from the system where the application is running. So what microservices tries to do is, instead of creating all the dependencies in a single box, I will run multiple services, or the microservices, spread out from multiple nodes, maybe, or even a single node, but it's decoupled from that node. So every time that service needs to run, I spin up the service does what it had to do, and then I shut down that service. Now, because it's decoupled from the operating system, if I have to spin up that same service in another system, it will simply run. Because it doesn't matter the configuration of the system. The service is self-contained, and that's where containers come up. So containers contain all the requirements for the application to run. So that's why containers are so important. Now, when we talk about microservices and containers as part of this story, we have agility because in order to spin up a microservice, you just spin up the microservice because it's just playing it. The microservice will run self-contained, right? I can build and operate at scale because different from most applications, when we build an application based on the microservices concept, because I decouple from the infrastructure, I can spin up multiple services. So I can have Load balancing and failover managed by the application, not the infrastructure. Think about it. All the applications that we have today, in order to provide high availability, what do? Cluster. Cluster is an infrastructure piece to support the application, right? Now, what if the application is aware of the failures in the infrastructure, and the application can remediate itself by simply spinning up a new service that does the same thing that the service that is down was doing in another node? I can do high availability and I can do load balancing at the same time from the application. I can continually evolve my applications because I'm running as a microservice and the service itself is easy to spin up. If I need to replace the application with a new version, I simply bring this service down and I bring the new version of the service up. That's it, right? I have faster delivery of features and capabilities because I can evolve the application rapidly. And I also, because of that, because the application is not tied to the infrastructure, I have a better use of my hardware resources, right? We're going to talk about this one specifically a little bit more during the session. Anyway, does this sound good to you guys? Sure, right? You guys can say that you love this idea or this concept. Who doesn't like ice cream cones, right? The problem is we are not dealing with ice cream cones today. This is what we are dealing with. That's the problem. We want to get to the ice cream cone, but today we have an ice cream, what is the name of this? Bucket or whatever, anyway. Container, right? So how do we get to there? We have one major problem here. The major problem we have is not every single application will be rebuilt in order to be working as a microservice or as a container or whatever the technology that you decide to adopt in order to move to a microservices approach, right? So how do we get there? Well, taking one step at a time, right? And at this point, we probably need both. We need the legacy application working, but we need to start working with the new applications in a new model, right? Now, the question that I get from customers at this point is, okay, Vinicius, so is there a way for us to take our legacy applications and move to something that is close to microservices? Yes, there is. Right. So let's take a look. Well, this is our North Star. This is where we want to get. If you think about infrastructure, what are the things that Microsoft is providing today? We have Windows Server 2016, our latest operating system release, and we have Azure and Azure Stack. And why is that important? Flexibility. You want to run in the cloud? Go for it. You want to run on-prem, your legacy applications? Go for it. You want to have a hybrid environment? Go for it. You have Azure Stack coming up later this year, right? Now, the most important thing, and that's a differentiator from not just the flexibility, but the real differentiator of Microsoft from the other vendors is the part above this. One of the things that we're doing is the Azure Resource Manager. How many of you know what the Azure Resource Manager is? Some of you. For those of you that don't know what the ARM Azure Resource Manager is basically a way for you to wrap all the components of your application and specify how to deploy those components together to form your application. If you think about an application is composed by database, website, the logic of the application, and so on, and you may have many components for your application, right? What the ARM does is basically declare all the components of the application in a single file. So if you need to deploy your application, instead of deploying each of the items of the application by itself, you deploy the ARM template and all the components are declared in this file. So when you deploy this script, you are deploying all the components. Now, on top of that, you can choose to run Windows Server or Linux as the foundation for your application, right? So in Azure and Azure Stack, as well as Windows Server, we not only support Microsoft technologies, we support Linux and other third-party technologies as well. And on top of that, you can choose if you want to run a virtual machine, which is basically to say you can run legacy applications the same way we've been doing this for a long time. You can run containers, or you can run, here it says Azure Service Fabric, but Azure Service Fabric is one step ahead of containers in terms of really decoupling the services from the operating system, also known as serverless applications. How many of you heard about serverless applications? So serverless applications means that I develop the service and I simply run that service in a platform that I don't even see the operating system. Think about platform as a service, right? So in Windows Server 2016, we are taking, from the on-prem perspective, we are taking the first step into this journey of moving my applications to microservices, or our North Star, which is make sure that the application is self-contained and we have all the benefits of using microservices, right? So by just installing Windows Server 2016, what are the benefits that I have? Well, first of all, you have a more secure environment. For those of you that were in my session yesterday, we talked about the features that we have in Windows Server 2016 for security, like shielded virtual machines, device guard, credential guard, just enough, just-in-time administration. Simply because I deployed Windows Server 2016 without any changes to the code, I can have a more secure environment, right, for my application. Another perspective is, for some applications, I can, without changes to the code, I can containerize the application and start taking advantage of containers, even without code changes to the code of the application, right? Now, the best thing to do would be if we would be able to either change the code of the application or for new applications, right? For those applications, we can choose to create the application already based in this microservices approach. But this slide is basically to say, look, if you can't change the code of the application, there is still some benefits for you because you are adopting Windows Server 2016. And there are some things that are not related to the application that because I adopt Windows Server 2016, I can start taking advantage as well. From the infrastructure perspective, there's a lot of investments as well. I had a session this morning on software-defined data center that will help you match the agility from the development perspective inside the infrastructure. To deploy an application, regardless if it's a microservice or not, the network needs to be there. The storage needs to be there. The compute power needs to be there, right? So there are other advantages as well. Okay, so let's talk about containerize some existing applications. The thing about containers that they were trying to solve is, and that's the reason why you see these images here. How many of you guys are familiar on where the term container was created for our technical space? You guys probably know a shipping container, right? You guys know how they used to do before the shipping container? They had no standards. The problem on moving stuff around the globe was that the ships were different from each other. The stuff that you are carrying is different. The sizes, the weight, everything is different, right? So how can I create a standard to move the stuff around the globe? Well, they came up with the idea of shipping containers, right? What we're trying to do here is exactly the same thing. with a few things that are specifically for the technology side. Like for example, I was saying about the story of developing an application, and when you deploy, the application doesn't run, right? We all saw this happening. What containers solve in that case is all the requirements for the application are already inside the container. So if I need to deploy this container in a different host, I don't care about the configuration of the host. As long as the host supports container, I can run the container. Right? Okay. Another thing that containers enable is this DevOps approach, or the agility that DevOps provides. One of the things that DevOps tries to enable in the companies that adopt this methodology is if you have new releases of your application, DevOps make it easier for you to deploy these new releases in production, right? And DevOps is actually a cycle where once the application is up and running, you can always feed the development team on improvements that can be made to the application. So you have this cycle of development and operations working together in order to make the application better, right? What we have here is, for a container, the developers will develop the application basically exactly the same way that they would for any other application, right? The only difference is that instead of packaging MSI or EXE or whatever other extension it is for Linux, they will develop a container. They will package the application inside of a container, right? And that container file is the file that I need in order to move to production. So one of the things that we can do with containers, and that's the part where Docker came up with the idea, is the idea of having a repository of containers. Let's take a look at this. I develop an application, and I create a repository of my container images that I can deploy containers from. So if I need to update the application, the development team will work on that application and simply bring this application to the repository, and operations can come and bring this application to production. This is pretty cool, right? Now, once the application is in production, you can use many management tools in order to check the performance, to see if I have errors in the application, and so on, just like you would do in any application. The good thing is, if I need to change this container specifically, the development team can rebuild the container, upload it to the repository, and operations can go and redeploy the container. In a regular application, because everything is tied to the operating system and the infrastructure, in order to do this, the development team can always update the application. The problem is when we move from here to operate to the production. Because everything is tied to the infrastructure, in order to replace that application, that's a hard process. With containers, I simply bring the container down, spin up a new container, and your application is up and running. It's that simple. Now, okay, so how can we create something like that, right? Let's think about a regular server running. We usually have the hardware, the operating system, and the application. So if you go back 10 years, that's probably the way you were deploying applications in a data center, right? Okay. We realized that this is not a good way to use the hardware resources. By the way, virtualization was created because we realized that we were not using the total potential of the hardware that we used to have in the data center, right? So what we did was we created virtual machines that extend the hardware to multiple operating systems. So every single virtual machine will now have an operating system and the application, just like the physical machine, but for this virtual machine, that piece of hardware belongs to the virtual machine, right? Virtual machine will see a motherboard, disk, processor, memory, just like a physical machine, right? You guys see any problem with this approach. It has been working for decades, 1 decade now, right? More than a decade. What is the problem with this approach? The developers in the audience, you have an application of 20 megs, right? It's a small application. Then you handle your package of your application that you develop so carefully to operations, right? It's your baby. And then you give it to the operations team. You know what the operations team gives you back? A virtual machine. What is the size of a virtual machine? You handle your baby and you get an elephant back, right? That's what happens with regular applications. The reason is because every single virtual machine, in addition to the package of the application, they have an operating system running on each of the virtual machines. And there's another problem now for operations. For every single virtual machine that I have here, I have to install the operating system, I have to patch the operating system, I have to back up the operating system, I have to maintain the life cycle of that operating system, plus the application, right? And there's another problem. This is a single hardware. If this hardware goes down, all the applications go down, right? Now, we solved this problem. We simply, again, remember when I was saying that because the application is not aware on the infrastructure, what did we do? Clusters. We bring another server that is connected to this server, so I can live migrate the virtual machine, or I can fail over the virtual machine to the other host in case I have a problem with the hardware of this host, right? But anyway, we solved the problem, right? This is what containers look like. I have the hardware, I have the operating system, and on top of the operating system of this hardware, I have multiple containers. So instead of virtualizing the hardware, I'm virtualizing the operating system now. That's awesome, right? This is exactly what Linux containers look like, and this is exactly the technology that we brought to Windows Server 2016. Now, the good thing about this is all these containers, they are isolated from each other, right? Just like virtual machines. The virtual machines are isolated. But in this case, I have a hypervisor in the hardware layer isolating the virtual machines from each other. Here I have a kernel that is common to all the containers, but they don't see each other. So think about this. When I start a container, I will see the operating system inside of the container, just like I would see in a virtual machine. But actually, all the changes to the operating system are only inside of this container because the kernel is virtualized. So the changes to the operating system are contained inside of the container. And all the other containers see the operating system as part of their own. They only see their operating system, right? All the requirements for the application are already inside of the container. So if I need to move this container to another host that looks exactly like this, I just move the container. All the requirements are already there. The only requirement I have for the host is that the host support containers, right? So Jeff was saying this in his general session yesterday. I didn't see the session today, so I don't know if he talked about this. One of the things that we do for Windows Server every time we are launching a new version of the operating system is we go to the common criteria analysis and we check the security requirements to see if we are going to pass all the requirements that they ask for the operating system. And the engineering team came to this a group of people and said, we are bringing containers to Windows Server. What do you guys think about it? Oh yeah, we know about them. We hate it. It's terrible. Wait a minute. Everyone is talking about containers. The idea of the ice cream cone, the microservice, looks like something everyone would like to do, right? Why do you guys hate this? There's one problem here. You see this kernel that is shared? You can't use shared and kernel in the same phrase. You just can't, right? That's a security issue. So then we went to the open source guys, and we asked them, what are you guys doing to solve this problem? Oh yeah, we know about it. We use virtual machines. You guys see the conflict? This is exactly what we're trying to avoid. And they are using to isolate the okay, we can't be in the middle of this fight. So at Microsoft, we'll do two things. We'll create a Windows Server container that is exactly like the Linux containers that exist today, and we will create a Hyper-V container, right? Now, that wouldn't work if I have to develop to a Windows Server container or a Hyper-V container. So one of the things that we did was you develop for Windows containers. The moment operations is going to deploy the container, they choose if they want to use a Windows Server container because, I don't know, that's still a development phase, or it's not a highly regulated application, or whatever it is. You can use Windows Server containers. If you're going to deploy the container that runs an application that is highly regulated, you have some requirements, compliance requirements, you can deploy as a Hyper-V container. Now, the difference between Windows Server containers and Hyper-V containers is that the kernel for Windows Server containers is shared between the multiple containers. In Hyper-V containers, the kernel is contained as well inside of the container, right? So no shared kernel, a hypervisor isolation between the containers, we're good to go. Now you can deploy containers in a production environment and meet your compliance regulations as well, right? Important point, remember, from the development perspective, there's no change to the code. I develop for Windows containers, right? Very well. What are the options that I have to deploy containers? I can have a physical machine, and I can deploy a container on top of this physical machine. That's probably, in terms of hardware utilization, that's probably the best way. I can deploy containers inside of virtual machines. Now, again, that's exactly what we are trying to avoid, right? But in a public cloud environment, the virtual machine is actually my host because I don't get to see the physical host, right? So the virtual machine in a public cloud is equivalent to the physical machine on-prem from the container perspective, right? You can mix and match physical and virtual depending on your environment. But the key benefit is containers will provide all the benefits that we talked about so far in this technology, and you can still meet your requirements, compliance requirements, and so on. So this is just to take a look at the architecture again. This is a Windows Server container. What happens is I have a server, I have an operating system on top of this server, which is the host operating system, and then you have, as a feature of the operating system, you have the containers, and each of the containers can share some libraries, which means that they come from the same container image, and they will have their application, but they are isolated, or they can simply be another container coming from another container image, right? Hyper-V containers, I have the server and the hypervisor, and when I deploy the Hyper-V container, at the moment that I spin up the container, I can choose between a Windows Server container or a Hyper-V container, and in this case, we will deploy within the Guest OS kernel inside of this Hyper-V container. Now, the next logical question is, what is the overhead for the Hyper-V container? There's some overhead, but it's minimal, right? We have some published public information about this on the Windows Server blog, if you're interested on that. There is some overhead, but it's minimal. The other point is, when you see Windows Guest OS, you probably think, okay, so do I need to manage this Hyper-V container the way I manage virtual machines? No, you don't get to see this kernel here. It's self-contained in the container. If there's any problem with the container, you will be notified of it, but there's no management to be made for this Guest OS kernel here. Okay, so with that, there's a lot of theory. Let's take a look on this working. So what I have here is we created a regular website. We will see that this is just the sample .NET application for Visual Studio. We deployed this website in Windows Server 2012 R2 in a VM. And what we are trying to do is we want to take this application that was not created for containers, and we want to containerize this application, right? So how do we do that? So let's take a look. There's no audio on this, so I'll explain what's going on here. So in order to show you the application, we are going to access the website. So Windows Server 2012/my site. So you probably are familiar with this interface, right? So this is the regular sample for the .NET application in Visual Studio. And the thing about this application is this application is consuming 3.1 gigabyte along with the operating system in order for this simple application to run, right? You probably have applications that consume way more than that. But part of this consumption is from the operating system as well, right? Okay, so you can see that it's consuming that. So if I go to IIS, this is my regular website that you guys are familiar with, the structure of IIS. So what I want to do here is I want to first export this application because I need to containerize the application inside of a container to deploy it later. So I go through the regular process of exporting an application from IIS. I'll export as mysite.zip. Okay, so now what I can do is I can go to, that's the file containing my application. Now I go to Windows Server 2016. In this case, it's a virtual machine, but could be a physical server. And let's take a look at the performance here. So in this case, this virtual machine has 3 gigabytes of memory available, and it's consuming at this point 1.2 gigabytes. Which leaves me with 1.7 gigabytes. Now, for those of you that are IT pros, when we open something like this, we usually see the IT pros are, oh my God, that's development again. No, that's just a script to containerize the application. That's not the application itself. What you see here is Visual Studio Code. Visual Studio Code is kind of a, they are recording, so I can't say what I was going to say. No, I can't. No one will see this anyway. It's kind of an evolved notepad, right? That lets you work with the code of the application because you can't compile the application on Visual Studio Code. You will need Visual Studio, the full Visual Studio to do that. So one of the things that we have for Visual Studio Code is an add-on to Docker. And you realize that at this point in the session, I barely mentioned Docker, right? And every time you probably hear about containers, you hear about Docker. One thing that many people don't understand is Docker is not a container company, right? They are a container management company, right? The container technology is a feature of the operating system. What Docker does is they talk to Linux containers or Windows containers, and they manage those containers. And they do this very well. That's the reason why we are partnering with Docker in order to create Windows Server containers. So anyway, what you see here is a file, a Docker file, that basically explains how to bring this application that I exported from IIS in Windows Server 2012 to Windows Server 2016. So look at what this file is doing. When you see from deploy, this web deploy is an existing container. So someone created a container, they deployed Windows Server on top of that container, which is the container image, the shared kernel, remember? So that's a Windows Server container. And guess what? Since that's Windows Server, that container can run IIS. So instead of creating a container that only has Windows Server, they repackaged another container image containing Windows Server plus IIS already installed. And that's the web deploy image that you see there. The rest is I want to expose from the container the port 80 and 8172 that are the ports that I need for my application to run. I will do that in a Windows Server anyway. And then I'll take the mysite.zip, which is the file that we were working on, and I'll copy to the container inside of the folder build/mysite.zip. This is a copy paste, right? And then look what I'm doing here. I'm running a PowerShell command that I will run inside of Windows Server anyway in order to deploy my application. That's simple, right? So all the learnings that you guys acquired over the years working with Windows Server is still valid for containers. The only difference is instead of running the command inside of a Windows Server, I put the command inside of a Docker file because the Docker file will say to the container what the container has to do in order to run, right? Okay, let's move on. We'll explain here from web deploy, blah, blah, blah. That's exactly what I was saying. There you go. So here, what he's doing is he's running the command docker build to run that file that I was working on and call it mysite. So this mysite will be the name of my container image. What I'm doing is I'm taking a container image, I'm bringing the application that I exported from Windows Server 2012, and I'm repackaging as a new container image. So now this container image, this new version of the container, has Windows Server, IIS, and my application. Now what I'm going to do is I'll run the command docker run that basically creates and starts the container. I will use the port 80 from the host. I'll map to the port 80 of the container using the image mysite. So take a look at what happens here. If I target the port 80 of this Windows Server 2016 machine /mysite, because that's the IIS website that I created, it will take a time for the first time that .NET runs, just like in any regular Windows server. But once this runs, there you go. I moved my website from Windows Server 2012 to Windows Server 2016 without changes to the code, containerizing the application, right? Now, one of the important things about this is, let me just go back a little bit. So take a look at how much I'm using now of the memory of this host. Instead of consuming all the memory like I was doing in Windows Server 2012, now from the 1.2, I'm now using 1.6 gigabytes, right? Let's take a look what happens if I spin up other containers, because that's just one instance of my application, right? So let's move in a way so we can all see what's going on. Take a look on how much memory we are consuming, 1.7 at this point. If I create a new container, 1.8, another one, 1.9. Now, let me pause this again. The question that most people ask at this point is, wait a minute, the first container used 400 megs to run, right? The next one used just 100 megs. Why is that? You guys remember that we are sharing the same kernel. So that's better resource utilization, right? So the next containers won't use exactly the same amount of resource to run. And to prove that the other ones are running, we changed the port. So if we run 81, or actually 82, the application will open now. There you go. Those are the 82 and 83. Now, I want to run this one as a Hyper-V container. What should I do? I simply use the isolation option to Hyper-V. That's it. That's an operational option. And one of the difference is because it's completely isolated, if I use Task Manager to see the process of the containers, you can see that I have the processes from the first 3 containers, but I can't see the process from the other container, right? From the Hyper-V container. The reason is because the isolation prevents the operating system on the host to see the processes inside of the container. So now we have 1, 2, 3, 4, 5, 6 containers, right? And I believe we are going to move again to the performance. We are using very little extra resources. And, yeah, there you go. We are using 2.9 for 6 instances of the same application that I was consuming more than 3 gigabytes to run in the other option. And one of the details here is that I didn't change the code of the application. Questions? Yes, the question is, how do we get that kernel? So it's the moment where you start the container. So you can't take an existing container that's already running and move to Hyper-V. You will need to turn off that container and start it again as a Hyper-V container. Because the moment we start the container, we will launch this container with user isolation or hypervisor isolation. Yeah, the question is, I can go back and forth between Windows Server and Hyper-V containers. Yes, in terms of scenarios, we are seeing the customers that are adopting this technology at this point. For development, they are using Windows Server containers, and when they go to production, they go as Hyper-V containers, unless they are running on virtual machines, and then they run as Windows Server containers anyway. Correct. What version of what, sorry? Oh, yeah, that's a good question. Yep. So let me just repeat the question. What version of Windows Server 2016 we are running here in order to be able to do this lift and shift? Before we talk about lift and shift, there's one concept that you need to understand. When I run, let me go back to that previous slide, because then we'll be able to understand. If I run as a Windows Server container, what will happen is the container application and the container itself will see what is the operating system that is running below the container, that is hosting the container. So if I'm running Windows Server 2016 full GUI or server core, the container needs to be server core because that's the container image available. If I'm running a Windows Server container as Nano, the Windows Server container needs to be a Nano image, right? Because they are sharing the kernel, right? So there's no way for us to run a server core container on top of a Nano. Now, that's not true for Hyper-V containers. Hyper-V containers can run other versions of the operating of the image on top of the container, depending on what you have as the container host. So if I have a server core for Hyper-V containers, I can run Nano or server core. If I have Nano, I can run server core or Nano, right? Now, for the lift and shift, the important part is that application needs to work on Windows Server 2016, right? So happens to be that that application that I moved works well in Windows Server 2016 as well as Windows Server 2012 and 2012 R2. Now, if you have your application working on Windows Server 2016, that's probably a case where the application can be ported and simply lift and shift to a container in Windows Server 2016. Make sense? Right? Okay. So in terms of customers that are using containers, this is one of the cases, Tyco International. They are basically using containers because they have multiple services running in multiple locations, and they need to be able to deploy services in buildings and multiple locations so they can spin up their application easily. They keep making changes to the application, and every time that they make a change to the application, they need to deploy it globally to the multiple locations that they are monitoring and so on. So this is one of the cases where they are using containers and are being very successful. Now, when we talk about containers and microservices, we are obviously talking about what we call as cloud-native applications. And cloud-native applications basically are applications that try to decouple from the infrastructure in order to have a better scale, agility, and so on, and all those things that we were talking about. Now, from the Windows Server perspective, there's an important point about born in the cloud applications, which is in Windows Server 2016, in Windows Server, historically, what we've been trying to do is we want to enable the operating system to run whatever the application may need or whatever the need for you is. So, for example, I need a DNS server along with my IIS application, along with whatever it is that you are running. So, the reason why Windows Server is a big image as it is because we want to provide you with all the features and capabilities that you may need from the server. Just checking how much time I have. And historically, we've been adding stuff to the Windows Server image, right? Now, a few things changed when we started to run our own cloud, right? Let me see what is the next slide here, just so I am, yeah. So, when we started to run our own cloud, Azure, there are a few things that we realized. For example, it takes a lot of time to deploy Windows Server. You guys probably know that, right? We didn't know. We don't deploy Windows Server. You do, right? Also, Windows Server images are very large. But you know what? That's something that we heard from you and we changed in the operating system because you asked it for. You remember the days where if you wanted to enable IIS, you have to go and take the media for Windows Server 2003, put in the server, and then install IIS. And then you guys asked us, can you please bake the content to the server so we don't have to bring the CD or the media every time we want to enable something? And we did. And sometimes we shouldn't. Right? What we are talking about here is this shift from applications that are monolithic and they need everything that the system could provide to applications that will run a service that is self-contained. All the requirements that the application needs is there. So the work of the operating system to host those services is make sure the service runs, right? We don't need a large operating system to do that. That's where NanoServer came in. NanoServer is not a new product. If you bought Windows Server 2016, you have the option to deploy NanoServer. NanoServer is just an installation option that is now available for Windows Server 2016. And it's kind of a different approach that we took when we created Server Core. So we realized that we needed actually a smaller version of the operating system back in 2008, right? So in 2008, we launched Windows Server 2008 with 2 deployment options. It was introduced in 2008. So when you're installing Windows Server, you have the full GUI and Server Core. And what is Server Core? Server Core is simply, we looked at the full GUI, we check what are the things that are not really necessary if you are simply running an application that you don't log into the server, you don't go in front of the server to log to the server. In order to run the application, you don't need things like Internet Explorer, even Windows Explorer. You don't need a lot of things that in order for your application to run, you won't need those things. So we took the full GUI server and we started to remove some things, right? What we end up with is Server Core. If you install Server Core and you go in front of the server, you log to the server, you will see a command prompt. The first time I saw that, okay, what do I do? Well, that's it. The other option you have is to type PowerShell, and then you have a PowerShell interface. That's it. You have nothing inside of the server. Now, you can still open Notepad. You can still open the Task Manager. There are some things that you can do. But the most important concept that Server Core brought was the idea of the remote management. Is this Server Core an IIS server, an Active Directory, a DNS server? Install the DNS, Active Directory, IIS interface in your Windows client machine, remote manage the server with the same interface that you are used to, right? With NanoServer, we took another approach. We thought, okay, so instead of taking the full server and starting to remove some things that we don't need, let's start with nothing and let's add what we need, right? So that's the main difference between NanoServer and the other installation options for Windows Server. NanoServer is a kernel. And on top of NanoServer, you add the packages that you need to run your application or whatever workload you're going to run in that server, right? So if you take the media for Windows Server 2016, you put it on the server. If someone does that still, not if it doesn't use an ISO file, anyway. You take the media, you put it in front of the server, you have still 2 options, full GUI and Server Core. You don't see NanoServer. Why is that? Because in order to install NanoServer, you have to take the media. There's a folder in there called NanoServer, and then you have to create your own image, which take us to another concept that we realized is completely wrong that we do. How many of you have the golden image in your environment? Some of you. That's bad. That's not good. You know why? Because the gold image is basically what we were doing with the full GUI. Let's bake into this image everything that I may need in all the possible workloads that I run inside of my environment. And we blast that image as the gold image, right? The problem is you end up with a very large operating system that runs a lot of things that you don't need, that you have to maintain, that you have to secure, and so on, now installed in every single machine in your data center. NanoServer takes the following approach. I have a website to run. I take the NanoServer image, I bake the web server package into that image, and then I create the image for my web server. That's it. In terms of size, ports open, services running, footprint, everything is smaller or better with NanoServer. But you have to create an image that was built purpose for that workload, right? So let's take a look at a few things. For containers, for example, I have two options to run containers. I can run containers on top of NanoServer or Server Core. Why would I use Server Core after everything that I talked about with NanoServer? Because there's one important thing about NanoServer. The idea of removing everything is really removing everything, including some APIs that some applications may call, right? So not every single application will work with NanoServer. You have to create your application for NanoServer in order for it to run. Now, with that said, there is a package for NanoServer that you can add as well to the image that does some translations for some applications that are calling some APIs that are not there. So then we translate those calls to the correct API. That's not the best way to do, but if you have an application that you need to run on NanoServer, that could work. You have to test. So if you have an application that was not created for NanoServer, you can use Server Core. It's a smaller version of the operating system and support containers as well. Okay, let's take a look at NanoServer.
I'd like to talk to you today about NanoServer. When you run setup from the Windows Server 2016 installation media, you're presented with two familiar installation options, Server with Desktop Experience and Server Core. We've included both of these installation options in several releases of Windows Server, and they're what can be considered as all-inclusive, meaning you get all the roles and features you might possibly need or want baked into the OS image, and you can install those roles and features at any time whenever you need them. Both of these installation options are also highly backwards compatible, and we go to great lengths to ensure that existing software and applications continue to work with each release. However, if you're building cloud infrastructure or hosting born-in-the-cloud applications, these traits aren't going to provide you the most optimized image. You really want something that is more purpose-designed specifically for the cloud. So allow me to introduce you to NanoServer. This is the server that many of you have been asking us for. When you think about the cloud, size is critically important, and NanoServer is tiny. Rather than 13.2 gigabytes, it has a disk footprint of 500 megabytes.
Let me just pause here, because at the time that we recorded this, it was 500 megabytes. At this point, it's less than 400 megabytes, the base image of NanoServer, right? Just like Jeff Woolsey said in the general session yesterday, for the millennials in the room, if you don't know what a megabyte is less than a gigabyte, right?
Rather than a reboot taking minutes, it reboots in under 9 seconds. Rather than 46 services running by default, it has 28. Rather than 27 ports open by default, it has 12. NanoServer provides just what you need and nothing more. We call this Just Enough OS. The roles and features are separated from the image, so you build images that are tailored for your specific workloads. This translates to real cost savings, lower storage cost due to a reduced disk footprint, less network traffic to copy and deploy operating system images, smaller attack surface due to fewer services running, processes running, and ports open, significantly shorter setup time, and just overall less to configure and manage. NanoServer is optimized for the cloud. It's the perfect OS for cloud scenarios. For instance, as a Hyper-V host, NanoServer uses fewer resources, allowing a higher VM density on the same hardware, as a scale-out file server, as a DNS server, and as a web server. The smaller attack surface comes in handy, given how web servers are classic targets for hackers. NanoServer's smaller footprint, fast deployment, and quick reboots are the essential ingredients for cloud scalability. NanoServer also makes a perfect app server for born-in-the-cloud applications and supports popular cloud frameworks such as Node.js, PHP, Python, Ruby, MySQL, Redis, Java, .NET Core, Nginx, and Go, just to name a few. And like other installation options of Windows Server 2016, NanoServer can be used as the base OS for Windows Server containers or Hyper-V containers. Another key difference from Server Core is that NanoServer is headless. However, we've designed it to be remotely manageable using familiar Windows Server tools like PowerShell and desired state configuration. Existing MMC snap-ins such as Hyper-V Manager, Failover Cluster Manager, Server Manager, and DNS Manager, or using the new browser-based server management tools. In summary,
let me just go back here. Are you guys familiar with this tool that he's showing here? So that's the server management tool. This is a Azure-based tool. So what this is a way for you to manage the servers that you have in Azure, on-prem, in AWS, on VMware, whatever it is. And you can manage Windows Server servers remotely using this graphical user interface, right? So if you have a full GUI server, you can use this, but that wouldn't make a lot of sense. But if you have NanoServer, that makes a lot of sense, right? Because on NanoServer, you can't go in front of the server because there's no console to log to, right? Not even command prompt and PowerShell. You have to run prompt and PowerShell remotely. So in order for you to have a tool to manage NanoServer remotely, we added server management tools to Azure, where you can see processes, registry, services, storage. So all the things that you would like to manage the server, you can do remotely in a GUI. So I really encourage you to take a look at this. Now, the other thing that I would like to show you, because I still have 3 minutes to finish. So if I have, oops. I believe I have a NanoServer virtual machine running here, yes. So this is a NanoServer. So first of all, let me start the virtual machine. Let me see if I have memory available to start this virtual machine. Yes. There you go, don't blink. Oops. There you go, the server is up and running. And by the way, we are running containers on top of this NanoServer. 3 seconds? Was that it? Right? Now, the question that a lot of people ask is, okay, so what happens if you log to this screen? Because when we first launched Windows Server during, NanoServer during the technical previews of Windows Server 2016, there was not even this screen. It was not an option to log into this console, right? But one of the things that we heard from customers is, maybe I created the image, I changed some configurations on the networking, and now I locked myself out of the machine. How do I go back? You have to redeploy. No, we have to find a way to fix network problems without re-imaging the server, right? Okay, so what we did was we added an option for you to come here and actually, let me try to zoom. Come on. So this is the NanoServer console. This is what happens if you go in front of a NanoServer machine, right? And the reason why there's this console is because you may want to change the networking configuration of this machine. So you can come here. There's an option down here that shows what you can press to change the configuration from static IP to DHCP or the opposite. You can come here and also configure the inbound firewall rules or outbound. Another thing that we added to NanoServer when we launched is if you install Hyper-V in this NanoServer, in the console, you will be able to see the status of your guests, like the virtual machines. In this case, I don't have anyone because I was testing containers. And I also have the option to see the VM switch, which in this case, I don't have anyone as well, but I could work in here to solve some minor issues with this configuration, right? So that's what you can do if you go in front of a NanoServer machine. Now, The rest works exactly the same way. You guys know Server Manager, right? When you install Windows Server, the first thing that pops up is Server Manager. You can remote connect to Nano Server. You guys know the MMCs, like Active Directory Users and Computers. By the way, that was not a good example. Active Directory Users and Computers not available on Nano Server yet. Let me take another example. DNS. The DNS MMC, you guys are familiar with that? I can remote connect to a DNS server into Nano Server. Hyper-V, storage, failover cluster, and the other things that I'm used to, like the application frameworks that he mentioned, right? So I just wanted to show you the console because it's kind of new after the launch. So the last thing that I wanted to talk about, I realized that I past the time here, is just the notion that Nano Server will also bring that is new to client. Server is kind of adopting a similar model, but not exactly the same. We have this concept of LTSB, is the long-term service branch. What that means is when we launch Windows Server, we start to plan for the next version of Windows Server, right? So a few years after this release, we go there and we release a new version of Windows Server. 2, 3 years, depending on which version we were talking about, there's a new version of Windows Server. For Nano Server, we are going to have, oh, by the way, this is still valid for desktop experience with full GUI and server core. For Nano Server, we'll have something different. We'll have the CBB. The CBB is the current branch for business, right? So current branch for business means that at some point, there will be an update for Nano Server for new features, not for security and fixes and those things. There will be a new feature update for Nano Server, right? We don't know what will be the time frame yet. We are still working on it. But in order to be able to deploy Nano Server and work on a CBB model, you need software assurance, right? Because you are getting new features every time a CBB is released. And the other point is, because we are releasing these new features, just like we do for LTSB, the 5+5 model for support, for Nano Server it will be a little bit different. For Nano Server, so if we look at the timeline in terms of features and time, we have Windows Server 2012, 2012 R2. We launched Windows Server 2016, which is the first CBB for Windows Server 2016, and Nano Server CBB 1, right? At some point, we will have other CBBs, and we'll have, at some point again, another LTSB version of Windows Server 2016. If you decide, if you choose to use Nano Server, you can't be more than 2 CBBs behind, right? We launched CBB 1, which is the launch of Windows Server 2016. There's CBB 2, you're good to stay with CBB 1. There's CBB 3, you have to move at least to 2, right? Okay, got it? Questions? No, you just don't have support anymore. I don't know about security fixes. I think there will be, because we are still launching stuff for the regular version of Windows Server. I would say security features, security fixes will be there. It's just the support. If you have support with Microsoft, you call Microsoft because you have a problem, we can't help you. Okay. Okay, so just to summarize, this is our North Star. With Windows Server 2016, we are taking the first step in order to provide support for you for this broad set of options that you have to deploy your applications. By simply deploying Windows Server 2016, you are already taking a step in terms of security, in terms of agility for applications and software-defined data center. You can choose to lift and shift applications to a container world, and you can target microservices more easily. Sounds good? Thanks, everyone. See you next time.